Anyway, welcome to the meeting. This is the February meeting of the Ottawa Centre of the Royal Astronomical Society. We'd like to welcome everyone here, whether they're regular attendees or whether it's your first time. You're welcome to come in and hang out, see what we're all about, and we'd invite you, if you're having a good time, eventually join up with the Society, and we'll talk to you a little bit about the benefits later on. So tonight's program, similar to two previous meetings, start off with our regular segment, Ottawa Skies, by yours truly. Al Scott will be presenting the 10-minute astronomy news this time around. Mike James talk on one of the lunar craters that you may or may not have looked at before. Eric Kuyala will be speaking a bit on a challenge that he started off with last time around. And then after the break, Chris is going to do the much anticipated talk on iPhone and I guess it's iPod applications for astronomy purposes. And we'll finish off with observations tonight. And just as a bit of an explanation, observations have been running a little long lately, and I didn't want to end up with Chris not getting his talk in yet again. So this time we're going to put it first, and if we run out of time, then we can get out the hook and pull the observations off at the end. Okay, so without further ado, we'll jump right into who's that guy. Okay, I need light here. There, good. Okay, clicker. Let's see, does it work? Laser works? Forward works? Yeah, okay. So first of all, just interesting item. I've been speaking for the last couple of months doing this segment and repeatedly mentioning that we're getting more and more solar activity over the last little while. It's becoming quite apparent. Actually, I popped that forward quicker than I should have. What is it? We're starting to see some fairly sizable coronal holes turning up over the last little while. We've been seeing several of them. An example being this pretty big one up here. And there has been an instance recently where we had two of them opposite each other on either side of the sun. So as it rotated around, one came into view as the other one disappeared. Now these are interesting. Primarily, they're a little different from the rest of the surface of the sun. You know, they're darker and they're colder, and they have lower density than the rest of the surface of the sun. They're associated with open magnetic field lines. So normally the magnetic field lines, you know, will come off and join at another point on the surface of the sun. But in this case, where you see the coronal holes, they don't loop around and come back to the surface again. They stay open. Well, this is an area where you see increased high velocity solar winds being released from these areas. So as they sweep around, as the sun rotates, we end up being sort of blasted with these fast solar winds. And usually it takes a couple of days between the time that one of them actually is facing us and the solar wind arrives here. But we'll usually see increased auroral activity, and we'll also see sometimes satellites will be affected. Either their flight dynamics can be affected, or they'll have charging of the skin of the satellite, and there can be damage to the electronics inside, that sort of thing. So I'm kind of excited. You know, this is all feeding into, we'll see more auroral activity, which is kind of cool for us to look at, and we get to see cool videos from time to time. So just a little bit closer shot of the same one. This one's from NASA, of course. Solar Dynamics Observatory. Actually, I see we have our titles a little low. They're clipped off on the bottom. But anyway, it's Solar Dynamics Observatory produced this one. There's also quite a nice video here that was shot. You can see one disappearing on the right-hand side and another one coming along on the left side. Here it repeats another time. It's quite an interesting shot. Also, Solar Observatory, right? Pretty cool stuff they're getting these days. We've now got enough of these solar observatories in orbit that we're getting a steady stream of interesting stuff to look at like this. Did I see his hand up in the back there?
Yeah, I just saw 3D Sun. There's a G2 geomagnetic storm's going to hit the Earth tonight.
Mm-hmm.
So keep watching the skies. We might be lucky.
Yep, exactly. Had that on the next line of my notes, actually. But yeah, G2 class, which is a level 6, and it's an arbitrary scale, but level 5 and above are considered to be storms, significant storms. I was checking just before the meeting, and the bar chart has just gone red since a couple hours ago this evening. So we've got a bit of a clear sky. You never know. We might see something turning up tonight. Okay, so just going on. I didn't have a terrible amount of stuff for lunar, and actually, I would like to get together with somebody who's an avid lunar observer. The more reading I do, the more questions I have about, in particular, timing, liberation, observations. Where to look, when to look, how to figure out how all that stuff's going. So, just for later, if somebody knows that stuff, I'd really love to get hooked up and learn a bit more about it. That's just me, right? It's funny, this job makes you look into this stuff a lot more than you normally maybe would. Okay, tonight, last time I talked about the unicorn, and this time around I'm going to talk a little bit about the constellation right above it from our point of view, about the same timing. So where I talked about Monoceros last time, it's about this time of year. It's pretty much straight up in the south after dark. Directly above that is Gemini. Gemini's, I think, a lot more popular, a lot more known constellation than Monoceros is. But there's a few interesting things. I picked out a few things for us to look at in there. So Gemini, the twins, it's actually been recognized as being two figures, usually two human figures, since very early times. There's records going back to some of the most ancient civilizations that we've got astronomical records from. And universally, it seems to have been recognized as being two humans standing there. The two brightest stars are the heads of the two people, Castor and Pollux, Castor being on your right, I guess, as you're viewing it from our point of view, and Pollux on the left. We'll just take a look here. We've got our sort of night sky, bunch of stars. Get yourself oriented. Oh, look, Orion, there we go. And there's kind of where we can start from. And up from Orion, through Betelgeuse or Betelgeuse, as you like, up in this direction. Oh, look, there's a couple of stars. There's your Castor and Pollux up here, okay? And the rest of the figures are coming down this way, so they got big feet. There's a big foot out there, and there's a big foot out there. So maybe we'll kind of draw the lines in a little bit. Can you see those lines? Yeah, okay. So, oops, I popped it forward one. So here we are again with Gemini, and what we're going to do. Oh, thank you, Brian. What we're going to do here, we'll just pull in a little closer. Here's the constellation boundaries. Formally, this is kind of what's in, what's out. And what we're going to talk about is partially in the Gemini itself, and partially it's actually in the northern part of Monoceros as well, but it's often associated with it. It's pretty close to the foot of. So we'll start off with Hubble's Variable Nebula in here. We'll just pop it out. It's an interesting looking object. It's one of the few variable nebulae. It looks different just about every time you look at it. It was, let me get my glasses on here again. Hubble's Variable, or NGC 2261, was discovered by William Herschel in 1783. Its variability is believed to be caused by dusty filaments that occasionally block the star that's illuminating this. So this is a reflection nebula. It's believed to be illuminated by a star R Monocerotis, which I believe is located right in the bright spot, kind of behind it there. Okay? And
Next slide.
yeah, good. Two people doing it, clicking at the same time. So it's believed that our Monocerotis is back in here, and it's illuminating this, but it's believed that there are dust filaments, opaque dust filaments, in between, and they're moving around, and so you actually see the appearance of the nebula change Sometimes even from day to day, when you look at it one day to another, it looks a little different. So interesting object, not too terribly hard to see. It's very comet-like if you're visually observing, but kind of a worthwhile thing to take a look at, tick off your life list, I guess. Okay, going on from there, the Eskimo Nebula, I think a perennial favorite, NGC 2392. So I keep mixing up the buttons here. Okay, really beautiful planetary nebula. Located just to the left here, right in that area, so not too terribly hard to find from Gemini itself. And we'll go forward here. Really nice view of that. I would say a magnificent planetary nebula. It's what they classify as a bipolar double shell planetary nebula. So same as any other believed to be an older star puffing off its outer layers as it exhausts its nuclear fuel. And you get these successive shells. Each time there's an event, it puffs off another shell. And some of them end up being really nice looking like this. Okay, the Eskimo was also discovered by Herschel 4 years later than Hubble's Variable Nebula. It was found in 1787. So this whole area, all of the objects that we're going to look at here, were all discovered by Herschel. Well, the first three are anyway. It appears, from the dates and from the same guy, he spent a lot of time looking around this area of the sky, all in around the 1780s, mid to late 1780s. So another interesting object. Like most planetaries, it's relatively small. So for visual observing, you're not going to see something that looks like this. Like, I don't want to disappoint people, but if you're getting out an 8-inch and you're looking at it, you're certainly not going to see anything like that. It'll be bigger than a star, and moderately bright. You might see a bit of color to it, but that's about it. You need something like the Hubble to pull out a really good image. Most of us don't have one of those. Okay, going on from here, Christmas tree cluster. So it's back down. It's actually in the north end of Monoceros, but another kind of perennial favorite. Now the Christmas tree cluster itself, we'll just bring it out there, is an open cluster. It's quite attractive, and it's quite easy to see visually and recognize. It's one of those things you can hardly miss. Now this is ESO. It's a really nice image, which no human at an eyepiece is ever going to see. But what you will see of this is the Christmas tree. See the bright, bright star, and then here's the nice shape. It's a very regular sort of a fir tree pattern, right? So you will be able to see that at the eyepiece without too much difficulty at all. Now, if you're going photographic, you get some really interesting stuff up here. At the top, you might notice this thing. This is the Cone Nebula. It's debatable whether anybody at an eyepiece, unless they've got like Attila's telescope, are going to be able to see the Cone Nebula. Have you ever seen it visually, Attila?
I haven't tried it from a dark sky.
Oh, okay. I understand it is achievable, but you need a pretty good telescope and a pretty good sky to see it. I would think, though, with this very sharp contrast between the dark and the light, that it might stand out enough under the right conditions. But, it's primarily a photographic target. Nice area, though, eh? Lots and lots of nice red emission going on over here. Okay, so what is it? The Christmas tree cluster was discovered in 1784, and the Cone Nebula was discovered by Herschel visually 1785, the following year. So he was hanging out in this area quite a bit. Okay.
Herschel was probably using his 20-inch telescope under a dark sky.
I would think, yeah. He had a very impressive speculum mirror, though, I believe. Wasn't it in that?
Yeah.
Yeah.
So, which means we could maybe see it in a 16 from really dark sky.
Yeah.
Say,
Yeah, a little bit of a handicap, but not too much. Size makes the difference, right? Yeah. Okay, and a last one here, what is it? NGC 2168, okay, which is Messier 35 in other terms. M35, open cluster, nice sort of circular arranged one. We'll go on here. It's what is it? Not discovered by Herschel. This one is discovered by Philippe Lloyd Chizot in 1745, so about the same time. This particular one, it's located about 2,800 light years away. Pretty cluster. It's about the size of the full moon, so shouldn't be too difficult to see either. Kind of nice if that's an easy one. What you might enjoy is looking for this one here. This is NGC 2158. This one's about 4 times as far away, so it's about 12,000 light years away. You can see right away much smaller stars in there. Looks like fine grains of sand, that sort of thing. But nice, interesting area to look at. Okay, planetary. Just going into that quickly. So what can you see? Jupiter's up. Early evening, sets fairly early. Uranus is disappearing, sort of last chance for a while, would be in the next week or so. Venus, early morning sky, not too difficult to see. Saturn in the morning sky as well. In Virgo though, so it's up, early enough that you can do some decent observing before the morning twilight starts to bother you. And Mercury, Neptune, Mars, and Pluto, not really visible. Like I suppose if you were in the right place, you might, but basically not worth observing right now. So just looking at them quickly, Jupiter's in the southwest in the early evening, sits about 9 or 10. And I've been talking about each month the southern equatorial band returning. It's you'll now see it is becoming quite significant. See, it's actually reforming now. The northern is quite red, of course. It's real solid, but now we're starting to really get a band back on the planet. So it's getting back towards its normal appearance. Uranus. Well, Uranus is a blue blob, right? There's not really much to be seen, but it's several degrees west of Jupiter. It's receding, and it's a viewable magnitude. If you get out there and you know where to look, it's not terribly hard to see. Going on from there, Venus, so the bright thing, right? About the only thing I find I can observe about Venus is the phases, as it changes. Best viewing, hour and a half before dawn. It's very bright, so you can check out Venus. Oops. yeah, just kidding. Okay, so actually NASA's got a lovely tool for visualizing Venus's phase. You punch in, the date you want and time, and it cranks out an image for you to simulate what it should look like. So that's roughly the phase you should see on the 14th, so mid-month, 10 days from now. That's about where it should be. Oh, real nice.
Where's that photo from?
That's computer generated from a tool that NASA's got on the web. Yeah, you just punch in the date you want and say render and blah. You get a...
It's not a real photo.
No, it's an image. Just a generated image. Yeah, it's pretty good though, eh? Yeah. Okay, Saturn rises about 10 or 11. It's also, it's highest in southern pre-dawn. North side of the rings are visible, so we've transitioned over. We're looking at the north side of the rings now. The rings are going to be tilted about 10 degrees by the time they get to their max, I guess. So fairly bright as well. In that particular case, a little bit of a challenge for you. The great white spot has appeared kind of unexpectedly. So everybody know what the great white spot is? I'm hoping not. I'm hoping I'm not telling everybody stuff that they already know. I'm sure there are some members at least that know about this. So what's the story? Great white spot. This was first spotted by Anthony Wesley, this particular occurrence. Now, this is not from Anthony Wesley. This is a Cassini mission shot a few days afterward.
Yeah,
but,
really clear skies that day.
Yeah, and an excellent webcam, I'd say. A really good job there. But huge storm going on. Now, the name Saturnian Great White Spots is, of course, a takeoff on the Jupiter, the Great Red Spot on Jupiter. The Great White Spots are just a name they use for periodic large storms that they get. Phenomenon is somewhat periodically. It's got about a 28.5-year cycle between when they turn up, usually, but it's not entirely regular. It usually appears when the northern hemisphere of Saturn is facing toward the sun. So they're not quite sure why that is, but nevertheless, when the north side's facing the sun, they seem to get more of these. And in this particular case, the recorded instances where they've been observed is like 1876. 1903, 1933, 1960, 1990. So the next one would presumably be about 2019 or something. So what's going on? We're seeing one now. Well, they do turn up sometimes when they're not expected. So this one was first spotted by Anthony Wesley, an amateur astronomer in Australia, on 22nd December of 2010, just last year. It's just like a month ago. Anybody recognize that name, Anthony Wesley?
Yeah, he discovered the impact.
You bet. Okay. He's the guy who just recently in the last year has twice photographed impacts on Jupiter. So he must have a camera trained on Jupiter like, every hour of darkness that there is. I can't imagine him having that much luck otherwise. He's got to be streaming it, to a server and just dumping images continuously. But anyway, here's another discovery first for him. And it's just a bit of commentary. Phil Plait wrote on this, and he was saying the main spot is huge. It's about 6,000 kilometers, which is 3,600 miles across, half the size of the Earth, including the tail streaming off to the right, or left in this case, because we're inverted. The whole system is over 60,000 kilometers long. It's just immense. It's huge. So, a fairly recent image taken here on 2nd of January by Don Parker down in Florida, I guess. Yeah, Coral Gables, Florida. It's obviously, it images pretty well. I saw some of Wesley's photos. Actually, I think Wesley's are a little better than this, but they're not as recent, the ones that I was able to find. But cool stuff anyway. Should be able to observe it, though, if you're looking at the planet. Okay, and I think that's it for me. So next up would be our 10-minute astronomy news, and that will be Al.
So welcome everybody for the 10-minute astronomy news update. I've got some interesting stuff for you this evening, so let me just see if I can hit the right button. Aha. So the first item of news is a question with hopefully an answer. Why are we all left-handed? Well, we're not actually left-handed in the macroscopic scale. It's the microscopic scale that I'm talking about here. And what I'm talking about here are amino acids. So it's a little bit of biology, and in fact, some astrobiology here. So these are representations of molecules with bonds between the atoms. And one of them is a left-handed molecule, and one of them is a right-handed molecule. And you can see that in that there's an orientation of two particular chemical groups represented by a blue and a white here, and a blue and a white here, and they're on opposite sides of this device, or this particular atom. And one is left-handed, and one is called right-handed. And although they have all the same constituents, and chemically they react mostly the same, it just so happens that amino acids, which are used to build proteins, can be left-handed or right-handed in the groups that attach to the carbon atoms. And the interesting thing about this is that life built on these amino acids is all made from left-handed amino acids. And nobody really knows why. Why is all biologically generated, why are all biologically generated amino acids left-handed? Nobody really knows. Well, it's kind of interesting because we figured that life based on right-handed amino acids would work just as well as it does in left-handed amino acids. And in fact, this would be a really good way to discover alien life, is that if you were to look at the chemistry of some sort of alien life form and find that it's based on right-handed amino acids, you would know that it's not from Earth or from what we're used to, having evolved from common ancestors. So astrobiologists could use this information. So the news aspect of this, in March of 2009, researchers at NASA's Goddard Space Flight Center, analyzing molecules in carbonaceous meteorites, discovered traces of amino acids that have formed in the meteorites. And they noticed by measuring the various ratios of the right-handed to left-handed type that there was maybe a 1% excess of the left-handed form of isovaline, which is an amino acid, in this meteorite that they were analyzing. They said, whoa, this is neat. Maybe this is why life on Earth is left-handed, that in the early Earth was seeded. There's theories that say the early Earth was seeded with organic molecules from these meteorites, these carbonaceous meteorites. And this initial left-right asymmetry then was amplified through autocatalysis and in life, basically, and became all left-handed, perhaps just by luck, starting from a small asymmetry. And so that was the theory. So now, recently, just in this month, new research has been announced looking at a whole bunch of carbonaceous meteorites now, looking at amino acids that they've been able to isolate from them, and found that it's prevalent in all of these meteorites, this 1% left-handed excess of amino acids. So this is really interesting. So the first time we found a source in nature of an asymmetry between these two things other than life. And in fact, the ratio between the left-handed and the right-handed is enhanced in some of these meteorites by a factor of 1,000. And these are the ones where they've seen evidence of liquid water having altered some of the minerals in the meteorites and destroyed some of the amino acids. So there's just traces of the amino acids left, and it seems like some process is selectively destroying the right-handed variant, or has in the past, when there was liquid water on these bodies, destroyed the right-handed variant. So that's really neat. So the question then becomes, what's causing this difference? Nobody really knows of any, or it's difficult to envision physical processes that will cause this. Well, and this gets into another concept. Light has a polarization. So photons of light have electric fields in them that oscillate back and forth, and they can oscillate in any direction as the light travels forward. And natural light that's emitted from the sun, say, has light of all different polarizations. It's in all different directions. It's oscillating up and down, left and right, side to side. Well, if you use polarizing lenses, say, in your sunglasses, that cuts out all but one direction of electric field. And that's then called polarized light that would hit your eyes if you're wearing polarized glasses. And it cuts out all the other directions and just get one direction through. And that's linearly polarized in one axis. So you can have linearly polarized light in one direction, and then in the other direction, or in any direction, for example, all the light then has their electric vectors, or their electric fields oscillating in the same direction. But there's another type of polarization which is relatively special. You can actually have light where the polarization corkscrews around as the light travels, and that's called circularly polarized light. And scientists have found in the lab, using circularly polarized light in an experiment like the Urey-Miller experiment, where you take some carbonaceous materials like ammonia and methanol and water and shine this light on them, it actually makes these amino acids form in a certain fraction. And by shining the ultraviolet light with circular polarization, it actually causes an excess of about 1% of one or the other handedness of amino acid to occur. So now we've found a potential mechanism that might be making this happen, circularly polarized light. But now you say, why does the solar system have left-handed polarized light in all of its carbonaceous asteroids? The sun isn't emitting circularly polarized light. Well, astronomers know that in certain extremely bright stars in star-forming regions, and light can become circularly polarized by passing through dust grains that have been aligned by the star's magnetic field. There's a preferential direction then, and that causes the light to corkscrew. And this is an image, a circular polarization image taken by the Anglo-Australian telescope. And white is a high concentration of one direction of circular polarization, and black is a high concentration of the other direction of circular polarization. And there's a star that's located, a bright star that's located in the middle here, and you can see that because the star's magnetic field kind of goes out in a torus around the star, there are regions of right-handed circular polarization and left-handed circular polarization. So the interesting thing here is that what this means is that our solar system likely formed in a nebula where there was a very bright star nearby with a strong magnetic field and lots of dust around it. And we formed in one of these lobes that had preferentially one circular polarization. And what that did was that it irradiated all these carbonaceous meteorites as they were forming in our solar system, and we ended up in the left-handed zone. And there was probably other star systems in this cluster that were forming in a right-handed zone. Because our star, of course, if it had circularly polarized light coming from the sun, it would have both polarizations because there's symmetry involved. The only way you can break the symmetry is to have one of these very bright stars nearby. And these things are huge. I mean, these are several tens of parsecs. So you could easily have several star systems in one of these lobes being formed. So this is the first time, I think, that we've actually had a natural explanation for what's been happening. And now that we know that this is forming, or this could have formed in the original nebula, meteorite impacts could then have supplied this material of preferentially one-handedness to the Earth. And this is very likely then what has formed the bias in life, is that we were just happened to be in one of these lobes of a star, a very bright star. We know that there was a very bright star in our vicinity when the solar system was formed because we've also detected radionuclides in these meteorites from radioactive iron, which have been caused by a nearby supernova explosion when the solar system was young. So we know that this is likely the case, and it seems to be a very interesting potential explanation where before there really wasn't a very good idea of how this could have happened. Yeah?
Then does that mean that we're wrong with looking into the right-handed amino acids or whatever cells for extraterrestrial life if we're looking at the other solar systems that are close to us that have been formed in that left-handed region as well?
It's a good point. What it means is if we do discover life on Mars, we can't use the left-handed or right-handed to determine whether it came from our spacecraft or whether it actually evolved on Mars. Because anything in our solar system that evolved is likely going to have this left-handed preference.
And anything close by, basically.
Well, the original stars that formed alongside the sun have long since dispersed. So any nearby solar system is not likely to have formed in the same lobe of the same nebula as our sun. So it's still a good chance that any one that you find from a nearby system is going to be randomly polarized or randomly handed.
And if I'm allowed another question, what does happen in the regions in between the left and right polarized light?
Well, nobody knows.
They're non-circular.
Nobody knows whether or not a handedness preference is needed for life to evolve. It may be that we're very special in having been in one of these lobes when we formed, and that specialness led to the evolution of life, for example. Nobody really knows, but that may be one of the prerequisites for life to evolve, to have a single preferred or handedness in the amino acids that allows them to auto-catalyze their production in these chemical cycles. So it's an interesting thing that's going to be explored by astrobiologists, I think, over the next few years. So next one, this is an interesting story as well. Occam's razor has potentially sliced a planet. Now, for those of you who don't know, Occam's razor is basically just a rule of thumb that scientists use, all things being equal. The explanation for something that has the least number of parameters necessary to describe it is probably the most likely, or the more elegant the theory, the more likely it is. The more extra parameters, extra things you have to add into the theory to make it fit the data, the less likely it is to actually be right. So in September, there was a news release from a group of people that have been observing the M-class red dwarf star Gliese 581, and they've been measuring radial velocity shifts of this star by looking at Doppler shifts over the last 11 months and collecting this data and trying to see if there are planets orbiting it by seeing how it's oscillating back and forth. And this is actually, these data points here are the points that they've measured over 11 years. And you can see that they've drawn a line through it which indicates a fit to the data, assuming a certain number of stars going around the planet. And using something called Fourier analysis, they were able to pick out certain periods, a set of periods in the data, and relate these to orbits of planets around the star. And the more intense the periods, and they can tell then the more mass in the planets. They can get an estimate of the mass of the planets and the period of the planets. And based on the known temperature of the star, they know where the habitable zone around that star is, where water is in liquid form. And these people have said that there's 6 planets orbiting this star. And here's the data of these 6 planets. You can see the velocity of the star is going back and forth by a few meters per second, and they're measuring this in the Doppler shift. So they can measure, with a precision they're thinking of on the order of 1 meter per second, the motion of this star several light years away, just by looking at the Doppler shift of the lines in the stellar spectrum. And then they can see, okay, here's a period of 3.16 days. There's a planet right in close, orbiting around the star every 3.16 days. And here's a big planet with a 5.36 day period orbiting the star. And here's one with 12.9 days. And here's one with 67 days. And these ones were known from earlier data. And what these people announced in September was that they've now gone further into the data and they're more confident. They've got more data now. And they've said that there's 2 more planets that exist. One is at 34 days and one is at 395 days. And this one at 34 days is right smack dab in the habitable zone. And it's going to be a 3 Earth mass planet, and it's going to have liquid water on it, and there's a good chance that there's life on it. Well, that's not a really good signal. I wouldn't say it's a 10 sigma kind of discovery. The astronomers looking at all of their known uncertainties in their data and their measurement system and in their models of the star say that there's less than a 1% chance that this is a false detection. When they announced this in September, they said, we know all the errors in our data, and based on our knowledge of all the errors, there's a less than 1% chance that this is a false detection. Well, just this month, a Canadian astronomer from UBC has published a preprint of what's called a Bayesian statistical analysis of the data. And what he's done is he said, well, looking at this data, there's noise in the data. And we know that there are a whole bunch of different parameters that could potentially fit just the random noise. So what are the odds that maybe this is just noise and it just happened to have fit one particular frequency of 34.36 days out of any number of potential frequencies that you could have fit, that there are hundreds of potential parameters that it could have turned out to be? What are the odds that this is just potentially noise? And he's done an analysis from this using simulations and Monte Carlo computer analyses. And the analysis he's done suggests the data is more likely to be caused by an additional unidentified source of noise in their measurements or systematic error that they haven't accounted for. And in fact, he says the likelihood of this data actually being a 6th planet is on the order of 0.01% to be true. So there's a bit of a discrepancy here between the two camps, and I'm sure they're going to fight it out in the journals. He says, these 4 planets, there's a strong probability that these are really planets, and there's maybe a 1% chance that this isn't a planet, and there are about 3 or 4 different periods that could actually fit the data for the 5th planet. But there's in all likelihood, the data as it is right now doesn't support this planet. It doesn't mean that there isn't a planet there. It's just that the data that they have right now is so noisy that there's much more likelihood that there's an unidentified source of noise that these people haven't looked at, haven't discovered yet in their system that's causing this. This actually, you can see the wave point plotted out here. This is the 4-planet fit to the data. So you can see there are some points that miss the fit by more than a few deviations. These are error bars on the points based on what the astronomers think their errors are. And you can see that either there's something else here or their noise might be wrong, their noise estimate. And that's very commonly the case in these difficult measurements, that there are some systematic noises, some jitter in the star, or even sunspots on the star pulsations that might be causing these things. So it's an interesting discovery. So keep watching on this one. So next, this is, I guess, my first time addressing you as president of the center, so I'm changing hats now. Thank you all for nominating me. I've got a request. For those of you who don't know, the center has a robotic telescope called SmartScope, and it was meant to be a millennium project of the center. And it's turned out to be taking about a millennium to get working. So this is a request for volunteers to help out. We've been making a lot of progress. It was actually, for those of you who don't know, it was a $50,000 donation from the Pett family, Hugh Pett, and in their honor, we've named it the Pett Observatory, followed by a $24,000 Trillium Foundation grant that allowed us to build this. And there's a building, there's a telescope. It's I think it's a 16-inch, and it's out at this. It's got all the robotic pier and robotic mounts, and it's hooked up to the web, and it's meant to be an outreach tool where you can do imaging over the internet from the safety of your home and the comfort of your home, and you can use this. And what we need to do is actually get someone who wants to be an observing coordinator. We're up to the point now where we're, from the work of several dedicated volunteers, we've actually got the safety issues. We had problems with the dome sticking open, which meant that we couldn't go public with it to the general public, because if the dome sticks open and it rains, then the whole thing gets destroyed. So we've had some people working very hard to actually fix these safety issues, and we're getting to the point now where in a month or so we're going to have the thing working. We need a few people to help out. You go in there and check on the telescope. It's 10 years old now, and it was working in 2003, but no one's really used it much since then. So we need to go back and brush the cobwebs out and make sure everything's working. So we're looking for volunteers who might have some time and be able to go in and help out, because the volunteers that are working on it now are stretched to the limit. But what we're looking for also is an observing coordinator, someone to develop and implement a method of observer training similar to what we're doing at the Fred Lossing Observatory, where you would probably give out, instead of giving out keys for a small fee, you'd give out passwords for a small fee to be able to access the website and use the scope. Someone to implement a method to monitor the status and notify the hardware people if there's a problem, and consider, the possibility for using this as an outreach tool to open it up to students, find ways to work this into the outreach program of the center as well, which is one of the goals that we had of putting this together. And you could, for example, have students submit observing proposals and then send their data to them and send the pictures that this thing generates. So if you're interested in helping out, we definitely need new blood, new volunteers to get this thing moving and keep it going and make the best use of it for the center. So please approach me afterwards or any of the members of the executive. Thank you.
And thank you, Okay, next up, Mike James to speak to you about Lunar Crater.
Anyway, I'm basically an armchair amateur. I've got a small scope, but my backyard has all sorts of trees. It's not a very good place to observe from. But I do occasionally look. And okay. Oh, there it is. Anyway, I look at the moon from time to time through a scope, and every time I've looked, I've seen a bright spot, which is out at the end of the peninsula. This is, I've never heard or read about it, but I know from looking at pictures, there are several others. That picture is reversed and upside down, but it shows Tranquillitatis, Nectaris, and Fecunditatis. Is this thing a laser?
Yes,
Central.
Yeah, and the bright spot is that one right there. It's more conspicuous when you actually look. That was taken with an Orion Starshoot imager with a single frame. So anyway, I looked at a map, and, which was courtesy of NASA's website, and the map doesn't show up well on a 20-inch screen, so I looked at a part of the map. Chris has been good enough to put a circle in the spot that I'm looking at. Yes. I homed in on that part, and you can see the general geography there. Lunography, I guess, or selenography. Even that one, even at that resolution, it's hard to see. So this is just homing in on the map. So I homed in a little further, and next.
Yep.
And there was still no obvious match. You can't see a bright spot there, but you can see enough. You can identify enough features that with the photograph or with memory of looking at it through the scope to actually pick the approximate latitude and longitude off this map. So, next, I searched NASA pictures for that, which they have nicely sorted out by latitude and longitude, or at least you can find them by searching on latitude and longitude. Now, this is the first one I found. It's labeled Censorinus, Isidorus B, and Mascaline. And it has Isidorus and Capella are the two craters near the bottom, which are right next to the antenna. And the bright spot is circled there. They have another, just trying to... This is a better picture of the same area, only it's upside down compared to the previous one. It has a NASA numbering system. It's also from Apollo 10. The looking further on the NASA site, they have this is basically the same picture as the one immediately before, but they've added notes identifying the bright crater there as Censorinus. That's that one, and it's about 5 kilometers in diameter, and that's Censorinus A, which is not as bright. So the source of that bright spot would seem to be this crater, and Isidora and Capella are much more conspicuous in this one. And the next one just shows it closer up, and again, you can see that it's conspicuously bright in that area. So anyway, my conclusion is that you can that if you see something that is that puzzles you, you can get a lot of explanation from NASA pictures. Oh, nope. That's the that should have been what went along with the. That's the same thing, just closer again.
Okay. Thank you.
And lastly, Eric's up here to talk to you about eclipses.
Does anyone remember last month, Eric LeMay did this beautiful series on the lunar eclipse that we just had in December. And I presented an impromptu lunar challenge, basically to find a photograph of the Earth during a lunar eclipse. This is not a photograph of the Earth during a lunar eclipse. It's a photograph of Apollo 17 photoshopped of what the Earth might look like during a lunar eclipse. But I want to ask you, did anyone find an actual photo of the Earth during a lunar eclipse? Anyone? No? Did anyone try?
Shouldn't ask that question.
Well, it took me all of about 30 seconds, thanks to Mr. Google. And the site I found it on was very strange. This guy, he's into Gothic stuff, and he happened to do a thing on lunar eclipses, which I found very bizarre. But there was a photo there of a lunar eclipse, if we can show it. This photograph was taken by the Kaguya Japanese space probe, which is orbiting the moon. I took the photo on May 18th, 2009. I thought maybe the NASA Lunar Reconnaissance Orbiter might have taken one, but couldn't find anything there. But this is one of the few actual photos of the Earth during a lunar eclipse. And I have to specify that it's only a partial, it's called a penumbral eclipse, which means the spacecraft is not quite in totality. So this is the photo that I found. And I actually thought it was interesting that no one's looked at this more seriously as a way of studying the Earth, because during a lunar eclipse, you have a very unique set of conditions under which you can observe the Earth with that kind of light. Obviously, we can't duplicate those conditions. They can only be done by the sun. And I thought maybe a station on the moon, almost dead center, where the equator and the meridian intersect, right at the middle, somewhere in there, might be a good place to put a small telescope that could photograph the Earth during the lunar eclipses, which happen, if I'm correct, there is at least 2 every year. Is that right? 2 lunar eclipses that happen at sometime during the year. So that's 2 opportunities every year to study the Earth from that perspective, which I think is something that merits attention, because we're looking out towards the stars and galaxies, but we need to look back at the Earth as well. It's very important.
I'll volunteer my telescope if you get it there.
Sure. After I win the lottery, we'll go together. Okay, and also I have a video that I want to show you. It's from an excerpt from the dinner meeting that we had in November, where Dr. Luc Simard talks about some of the applications for the 30-meter telescope being built in Hawaii. And it sort of ties into this, because he's talking about how we can actually learn about a planet by the light that goes through its atmosphere and then to Earth. And that the 30-meter telescope will actually be able to analyze what is on the planet by seeing that light going through the atmosphere of the exoplanet, which is, they're very far away. And we'll actually be able to learn more about planets that way, which is similar to this idea where we're using the sun as a backlight. Can we play the clip?
I don't work on exoplanets and life in the universe, but one thing that this telescope will do really well is give us a better understanding of planets around other stars. The first thing we're going to be able to do is, if you look at this star here and the scale, 1 astronomical unit is where the Earth, the planets like the Earth are found, terrestrial planets. And you can see all kinds of interesting molecules in space, like water. How do we take those molecules, which are present throughout a protoplanetary disk, how do we take those molecules in space and put them at the surface of new planets? We don't know, but with TMT, we're going to be able to observe molecules being deposited at the surface of newly formed planets. One thing that we hope to do is find actual traces of life. And I'm not talking about ET phone home. It's actually kind of cooler than that. So here's a star, and you have a planet around that, passing in front of that star. So the light is going, the Earth is way over there. And so the rays from the star will go through the atmosphere of the exoplanet. And if we can measure the spectrum of these light rays that go through the atmosphere of the planet, we can measure the chemical abundance of atmosphere of planets around other stars. So if we can measure the chemical abundances of those atmospheres, and we find something like oxygen, oxygen exists in the atmosphere of the Earth because of life at the surface of the Earth. If there was no life, oxygen would quickly react with a bunch of other stuff and disappear from the atmosphere. If we find significant amount of oxygen in an exoplanetary atmosphere, it would be a strong evidence for life. And in fact, we're going to be able to tell you whether a planet is covered by water or whether it's covered by a forest or just plain rocks.
So that inspired me when I heard him talking about this, the light going through the atmosphere. Maybe putting a station on the moon, we could refine that technique. And because we know what the Earth's atmosphere contains, it would be a good way of calibrating that technique so that when we do look at other planets very far away, we better understand what we're looking at. Also, I have some videos to give. Is Sanjeev here tonight?
Yes, he is.
Okay, Sanjeev, I have some videos for you, for Gordon Webster and for Chuck O'Dale. I'm very happy to give a video to someone who's done a presentation here. Just come and see me, and I'll provide one for you if you do a presentation. This is my way of thanking you for doing your presentations. They're very instructive. For me, this is a labor of love. I do this freely and enjoy it very much, and I want to thank you again. Next month will be my 3rd year filming, and I have not missed a meeting in 36 months. Thank you.
Okay, next up, the long-awaited discussion on iPod, iPhone, and iPad applications by Chris, our wonderful slide presenter.
Thank you, Bill. It's, as he says, it's long anticipated. More, it's been in our mind between Bill and me for months to do a talk like this, and it's taken a while to get it together. And I'm actually glad it's taken a while, because every month we delay, more is new and more changes. So my talk started, as you see here, as astronomy apps for the iPhone, and I'd planned it for December or January. And you may have seen a lot of media attention over Christmas, sort of slow Christmas sales, with one exception. Sort of the real present this year seemed to be the iPad, and it's amazing what that has done to astronomy apps. And this talk has really morphed into, of course, iPhone apps for the iPhone, and the iPad even more so. Just a little diversion. My daughter, of course, loves these iPads, but she refers to hers as her eye tampon. I haven't met a girl yet who likes them and wonders how they got this name, and says it had to be a committee of all males that chose that name. But still a wonderful product. If you go onto the Apple iTunes store and just type in astronomy, you end up right now 367 different apps for iPhones, another 111 for iPads. Mind you, they often are the same ones in duplicate, but it just shows you there's an enormous number of people out there writing apps for this new device, and not all of those 367 are really directly related to astronomy as we know it, but a large number are, and a lot of fascinating material in that. If some of these are of specific interest to you, oh, sorry, wrong slide. What I've done is gone through a lot of these apps, and just on my own personal choice, picked out quite a number here that I think are of interest. This is somewhat random and somewhat personal. I'm sure there'll be people in the audience who will say, oh, you should have tried this one, there's another great one, and I'm sure they're right. There'll be lots more out there. But I've picked all of these, which I'm going to fly through tonight. Won't spend much time on each one of them. And I've just subdivided them myself into these categories, try to give you some comparisons within each section, particularly in the first section of planetarium programs and what a typical application is able to do. If some of these are of specific interest, rather than taking notes, this is a sneak preview of my last slide, which will come later on, which I have available as a handout. So if you're interested in wanting to know which of these apps that I referred to, what they're worth, which platform they work on, you can pick up this handout at the end and not have to try to take notes right now. But first, some basics of how astronomy apps fit on this platform. And there's really 3 components in an iPhone or an iPad that make this possible. And that is most devices, I'm going to tell you the exceptions in a minute, have a GPS built in. And that GPS, of course, gives you 2 things. Gives you your exact location, and equally important, gives you the exact time. Then most of these devices have a digital compass. So as you hold up your iPhone, it knows exactly which direction it's looking at. And then most have an accelerometer, and therefore it knows what angle it is being held at. So you combine the fact that this knows exactly where you are and knows exactly which way you're pointing and at what angle, it knows exactly what you're looking at in the sky. And you can see from there the combination of that material with then computer programming and planetarium program becomes very, very useful. The caution, though, I say in this is that the 3 devices I just described are, I believe, in all iPhone 3s. They are not in the older versions, iPhone 2 and before. The GPS does not exist in an iPod, and the GPS does not exist in the basic model of iPad, but it does exist in the 3G model. So if you don't have one of these devices that has all three functions, most of what you're going to see tonight still works, but not the first application of being able to hold this up in the sky and know exactly what you're pointing at. Also, the big difference between the iPhone and the iPad, very graphic on this screen. On the left is a screen capture to scale compared to the image on the right of an iPhone, and the blue box on the right, the large outline, is the size of an iPad, proportional to the iPhone. You can see it's a massive difference. But when the iPad first came out, most applications that were written for the iPhone, when you loaded them on an iPad, looked like what you see on the right. The same small image, taking no advantage of the large screen size. Except most of them have a little button, you see it here 2 times, and if you press on that button, the image is simply stretched to fill the iPad. Easier to read, but it's the same image. In fact, it's even fuzzy on the iPad because it was never meant for this size of screen. But suddenly in the last month or two, as more and more programs are being written specifically for both platforms, when you now take this same application, happens to be called Go Sky Watch, and put it on an iPad, you now get that. So in other words, programs now are written to take advantage of the huge screen size and not just blow up the same small fuzzy image from an iPhone. But you can see on the right, you put a lot of material and very clearly on an iPad. So I'm going to walk you through a variety of what I call planetarium programs. In other words, these next ones all try to map the entire skies around you and use the function I first described of being able to hold the device up in your hand, point it somewhere in the sky, and know where you're looking at. This first one happens to be highly publicized by Apple themselves, won a lot of awards, and you can already see from its opening screen what I call sort of very visually rich. Nice background, Milky Way there, all the planets and stars are identified. This one happens to turn on the zodiacal image of the constellation that you're pointing at, though that can be controlled. But starts off with a very sort of visually rich screen background. All of these programs have built into them the obvious catalogs to help you find an object. So if you look across the bottom of each of these 3 images, there's 5 different buttons so that you can choose whether you're looking at a constellation or you want to find a solar system, deep sky, and so on. And as you look at each one of the screens, you can see how the names are in 2 different brightnesses. Obviously, the dull ones are not visible at your current location at that time of day, and the bright ones are. So it quickly tells you what's up. You press on the object and move to it. Throughout this talk, these first ones I'm going to use as an example, just trying to go find the Orion Nebula, M42. So using the catalog that you saw there, you would pick a deep sky object, choose on M42, and as soon as you say, please find it, you see on the left image the large green arrow. It simply takes you by the hand and says, please start turning to the left, and that arrow keeps on moving until you are pointing right at the object. And when you are pointing at the object, on the right-hand image, it then expands in size. In this case, shows the astrological image of Orion, and you know you've arrived at that object. Once you get there and touch on the object, or use your fingers to pinch and expand or contract the screen, in this case expand, you can zoom right in, and as you zoom in on Orion, obviously it starts to show more stars, turn off some of the background images, label more stars, and as you keep zooming in and then finally touch on the object, you get the typical screen here with lots of information and a pretty picture on an object, and this works for most objects, and certainly all the major deep sky objects in the sky. This particular program, I started into the planetarium side, but its opening screen is the one on the left, which focuses on what are the solar system objects today. Where's the sun, sunrise, sunset, what phases of the moon, when it will be at the next phase. Here, focusing on the 4 planets that are visible with the obvious data of when you're going to see them. Again, if you touch on any one of these, it then jumps in. I show you Mars on the right and gives you lots more information on Mars and a pretty picture of it. Though in this case, it's a static image that's not showing you how Mars might be this moment.
Question?
Yeah.
In all these things you're showing, there are 2 pictures, 2 screens. Are you doing that just for convenience tonight?
Yes.
Or would you hold this thing in landscape mode, as it were, and look at it sideways and see the 2 at once?
No, these are just putting two images on the screen at the same time. Here's a second very similar program called Go Sky Watch, also sort of very popular reviews and won many awards from Apple. Same general approach. You see on the right a very visually attractive screen. A lot more objects are turned on here, and in most of these you have good control yourself going into the settings and deciding what objects are going to be shown here. I've turned on quite a large number of objects, deep sky objects, though not turned on their labels. And you see at this wide angle view sort of a very pretty Milky Way, though if you try to zoom in on it, it doesn't get better as it goes. In fact, it gets quite fuzzy and poor. So it's very visually attractive at the beginning, but there's not a lot of depth to it. In this particular program, again, when you click on an object, again, M42 here, in this case, it brings up a dialog box right away showing you the object. But if you look carefully at the bottom right-hand corner of that box, there is a small arrow, and it's the same as the large arrow you saw in the last one. It's pointing you where to move until you find the object. And then on the right, same screen with that box gone, this particular program has this strange cursor in the center where there's a tiny circle in the center, and whatever in the background comes into that circle then shows up in these four places. So you get a pretty picture, the name of the object, the constellation it's in, and its RA and deck. Sorry, let me go back there. Pick both of those as really good examples of one style of planetarium program, and I describe them, I keep using the same word, as visually rich, but that's about it. There's no depth to the program. There are none of the features that we in this room as sort of amateur astronomers might come to expect in a planetarium program. These would be fantastic for a non-amateur astronomer, a neighbor in a backyard who looks up and can't tell whether that bright spot is Jupiter or Venus. This will certainly tell them, how come we can't find Orion in July, or where is Orion tonight? Say very visually rich, great for absolute beginners to find your way through the sky. Then I'll move to a very different kind of program, and had I given this talk last month, it would have been the program I stopped at as sort of my preferred program. You can already see from the image on the right, nowhere near as attractive. It doesn't have the same kind of background imagery in Milky Way and so on, but an accurate depiction of the stars and constellation figures. It, like the others, has the same kind of catalogs. Again here, if you look at the bottom, planets, constellations, stars, what's visible tonight, and so on. And the same thinking of the highlighted objects are visible tonight and the dim ones are not. Again, on the left, the same kind of arrow system that points you across the sky to find the object. And when you tap on that object as you get close, as you progress across these screens, you get increasingly larger images and fairly good detail, data about the object. So far, that's the same as the previous one, though maybe not as visually attractive. Here's the first hint, but there's lots more coming of then sort of the deeper features. When you press on that button called Tonight, it gives you this neat little bar highlighting what they think are the major objects that are visible tonight. I don't agree with many of them, but it does show you, that Andromeda Galaxy is going to be up tonight, but setting by 3 in the morning. This is where the program is totally different than the previous two. Is this map or this settings screen with lots of different menus. So across the top you have the ones I've already referred to, the catalogs that help you find planets and constellations, but there's lots more down here. Let me walk through some of them. Things now that we do take for granted in larger programs that weren't in the previous apps. The ability to turn on telerad settings to scale, that they changed as you pinch the screen and enlarge or compress the view, the telerad accurately portrayed on the screen. Then in the middle screen there, you're able to go in and input the specifications of your telescope, your various eyepieces, your CCD camera, and then project on the planetarium program the various fields of view. I didn't mention there your finder scope as well. So if you look in the top left corner of the right image, I have programmed right now a 32 millimeter eyepiece in my telescope, and then that is the accurate field of view for whatever observing device you're using. Again, unlike the first two programs, this one has built-in databases of comets and asteroids. And in the top right of either of those screens, you see the load button. You press that button, and 1-2 seconds later, it's downloaded the latest database. So you have up-to-date comets at all times in your planetarium program. A few cute things, not critical, but a simplistic logbook function for you to record what observations you've made. The center is a built-in timer, whether it's in a stopwatch sort of countdown or count up mode, with little buttons to help you. And if you're working in CCD imaging, you plug in what time you want for each of your exposures, and then keep hitting reset for the timer and counting down for your exposure, your dark frame, your flat field, and so on. Yeah, cute and fun, but and then the one on the right, built-in flashlight, so the whole screen goes any color you want. Obviously, red being obviously the first choice. You control the intensity. But where it gets much more sophisticated than the first programs is built-in telescope controls that operate most modern go-to telescopes. So with a handheld device standing away from your telescope, you're able to then use the planetarium program, and if you like M42, hit go-to, but no longer on your scope, but on your iPhone or your iPad. On the right there, you see a list of some of the telescopes that they support. My recommendation, say, last month would be that program vastly superior to the first two, even though it's not as visually rich. Its huge pitfall was that it only works on the iPhone scale of screen. It's one of those that just expands the image for an iPad, but it's no better. And last night, doing some last-minute checking of data, what do I find? They've just released the iPad version of this program, and I've just stolen some screen captures from their website. But clearly, you can see from these two images compared to the last ones, they now fully support the large format screen. So this would really improve the usability of this program for people. By the way, all of these programs, or sorry, not all, most of these programs, but not this one, I have here tonight on both an iPhone and an iPad, and you're welcome to come up later and play with them, see them, and so on. This is the one I've just discovered that jumps up to the top of the list for me, called Sky Safari. It's one, unlike the others, that has its roots in an existing planetarium program meant for computers. It's also sold directly from Orion telescopes, and you'll see why in a minute. They're the producer of the hardware that lets you connect these devices to a telescope. And it really combines fairly good sort of visual attractiveness, like the first two programs, with most of the features of the previous StarMap version. So while I still prefer StarMap in many ways, this one's almost sort of the best compromise between them in having lots of features and fairly good visual attractiveness. So again, there's the large iPad version with lots of detail. The same kind of catalogs, in fact, far more catalogs than any of the other programs. So now it specifically has, Messier catalog, Caldwell objects, just double stars, nearby stars, lots more selection. And again, the same idea that it shows you which objects are current right now. Here I'm starting to zoom in on the same M42. And as you zoom in here, the background image really does improve as you go. It doesn't just get larger and fuzzier. And just, again, naturally, all these programs, as you zoom in, know to turn on more stars, more star labels, and so on. And take a look at the image on the right. There's always a frustration for me in these meetings that I get to see great images on the computer, and I know up here they're often ruined. But no, you can even see, for instance, on Orion. Oh, sorry, wrong button. On Orion, as you zoom in, even Barnard's loop showing. So it's not just the same fuzzy image of the first ones that doesn't stand for scrutiny when you expand on it. Again, as you tap on any one object, lots of detail comes up, and this program has far more information on each of the objects, far better pictures. It's really very well done. Here, as you zoom in on planets, you're now getting accurate depictions of the moons and where they are. In fact, look at this one. You're even seeing a transit across Saturn, which is accurate for your location and time. Again, like deep sky objects, as you zoom in on a planet, you also get large screens of data on that particular planet. This one does the moon well, where the others don't do it at all. So on the left, you see just the data screen of information on the moon, but on the right is a dynamic image of the moon where the phase is accurate, and you can control the phase, either what it is now, or you can shoot ahead or behind in the lunation and see the accurate phases of the moon. Shadows, I'll talk about in another program. This one has a built-in animation feature, so you can set the timer going, and this is one image. All these images I've taken off my own phone, except for this one on the right, where I've taken from their website, but they claim you can even reproduce eclipses and see what's happening with the animation program. This one has also by far the best control over the screen. So on the left, I have the basic settings screen open. You see the various choices of setting the time to now or sunrise or sunset or any day location you want. But on the right's an example where you can go into any one of the items on the left half of the screen, right here, and for every one of those, the right-hand screen fills up with choices. So I'm on deep sky, and you start to choose how much detail you want displayed on deep sky objects. Including, when you get into stars, you choose the limiting magnitude based on your location of what stars show on the display. So becoming very, very useful. As you zoom in further, get lots more detail. And in this screen, you see at the bottom, superimposed on the image, this program also supports telescope controls. Now you ask, how do you control a telescope from a handheld object? Two ways of doing it, and you can see them both very graphically here. On the left, you can now buy a cable that obviously on one end is the fairly unique jack that's on the base of any iPhone, iPad, iPod. And on the other end of the cable is the standard serial port, since I think most go-to scopes use a serial setting. But more interesting, on the right is a Wi-Fi device. You take this device and install it on your telescope and just plug it into the RS-232 port, and it interfaces with the Wi-Fi function on the phone or iPad, and now you have wireless control. So you can be sitting with the kind of visual richness of screens that I've shown you in a public setting on a screen that big, and say M42 go to, and the scope over there will go to it.
Wow.
It's impressive what they're doing. On the right, I'm not sure if you can read that text, is a longer list of the scopes that are supported by the Wi-Fi module. Okay. That covers the planetarium apps. You can see I've got a lot more. They'll take a lot less time to do, but Bill tells me we're running short on time. It's already approaching 10. We have lots of observations. So I gather what we'll do, Bill, is stop it there, and then next month maybe finish off on all of the other apps. They do go a lot faster. I took a lot more time on the first ones because they're the most obvious apps that we'd be using for overall observations. Right, Gary?
Just show of hands, how many people have iPhones?
Show of hands, how many people were playing with their iPhones while he was talking?
I hope you were looking at astronomy apps. Let me just jump. No, not switch.
Oh, okay.
Bear with me while I jump way ahead in this talk. If I can get my mouse to work.
Oh, there's still black screen here. Hang on.
Chris, did you mention anything about real-time updates? Like if you're actually watching something, like a lunar eclipse, for example, does it update do the apps update that automatically?
Sorry, I'm not following the question.
Basically, like, as you're using these apps, they're being updated
Yes.
from a server in
No,
real time.
not for a server. If you have the time setting on now, then it's accurately showing you what based on the time of your iPhone. So yeah, the image should refresh itself and be accurate at all times. This, I gave you a hint at the beginning, is my last slide, and only the first part of it will make sense tonight. But I do have this as a handout. It's a list of all the apps that the first ones I've reviewed, the planetarium programs, sort of up to here, and in another talk I'll go through all of these others. But you can see a lot of information here. Many of these programs are free of charge. Wow. Lots of them are 99 cents, $2.99, but you have to be careful in buying these because there are different flavors of them. Some of them are specific to iPhone. For instance, this top one, you see one price here in the iPhone column and a different price in the iPad. So clearly, if you don't need the extra screen size, you can get it for less money. Some of them here, as you see, a dual price, but it's in both columns. In fact, that's my preferred program, Sky Safari. There's basically often a light version for free or a light version for $2.99, a far more sophisticated version with telescope controls and more stars for $14.99, and it works on both platforms back and forth. And you buy it for one and you have it installed on both phones. The sad thing here, look at the last column. I'd love to be a good patriot and be using our Canadian product, but there's just nothing in the astronomy field that I can find for BlackBerries. None of these exist on BlackBerry, and I've gone looking for other apps on BlackBerry and found essentially nothing. Sorry, I have a question there?
Yeah, have you found any of these on the Mac App Store?
All of them I've got from the iTunes App Store.
No, but like in terms of being able to use them on a Mac, because I know that Apple has now put out their, basically the iTunes for the iPhone and iPad equivalent, but for the Mac. So I'm just wondering if you saw any of that on.
No, I haven't looked for it. That's news to me, and so I'd love for people afterwards to tell me that I've missed a major one, so that as I continue this talk, I can highlight. I know Karen mentioned distant suns she knows and likes. So I'd love to hear from other people. And say you're welcome to come up later and see any of these on either of my two devices here. Okay, thank you.
Thank you, Chris. Next up, we'll go to our observation report. Okay, we'll start off with Paul. You need a microphone, Paul?
No, I don't.
Okay.
I have taken 3 photographs of 3 open clusters in Cassiopeia, and I'll show them in the order of right ascension. The first one is NGC 436. The size is 6 minutes. The magnitude is 8.8. There are 30 stars in there. It's also known as Colinder 11 or Melot 6. The photograph was taken on October the 11th, 2008. Second one, please. Next.
Is it advancing?
NGC 0581. That's M103. It's also in Cassiopeia, 6 minutes in size, magnitude 7.4. The number of stars are 25. By the way, the age of the first one was 79 million years. This one is 22 million years. The first one was 7,172 light years away, and this one is 8,476 light years away. Photograph also taken on October the 11th, 2008. Next. This is NGC 637, also known as Colinder 17, open cluster in Cassiopeia, 4 minutes in size, magnitude 8.2, number of stars 20. Distance is 6,846 light years, and don't have the age. All these, by the way, are B5, B2, and B0. So that means that they are formed with very bright, short-lived stars. You should note that these clusters are younger than the Earth. These clusters are a matter of a few million years rather than billion, as opposed to the age of the solar system and Earth. So if the dinosaurs had telescopes, they would have been able to see these things being born.
Did they?
Who knows?
So, thank you.
Thank you, Paul. Next up, Tony Peterson.
What button do I push?
Pointer?
Just a button to push.
No,
Here?
no, no.
Oh,
no.
you do it all?
Where's the button?
Right here, the right-hand one.
Oh, okay, this is my first time up here,
Yeah,
okay.
and the laser is the big button.
Oh, yeah, okay. Okay, so very quickly, and I have 3 images to share with you tonight. They were all captured with the same kit that you see here, the business part of which is an Orion 120 millimeter. Captured at Mew Lake, November 8 and 9. I wish I had more recent images to show you, but obviously there have been too many clouds between now and then, so I haven't been out at all. Horsehead, 12 times 1,000 seconds, and the Andromeda Galaxy M31 is a 3-frame mosaic, 10, 8, and 7 times 1,000 seconds. I had pretty good condition. Well, I had superb conditions. Excuse me. On November 8th, just a slightly high humidity. My hair dryer was very busy. On November 9th, the air was very dry, crystal clear skies. Probably the best night I've ever experienced with the telescope. And it's a dark site, so I needed no filters. There's the horse head. What I like about this image is that it's got thanks. It's got very low noise, partly because there's 12 good frames in it, but also the very low temperature. I froze my keister off taking these pictures, I promise you. But there were some slight technical flaws, but we're short on time tonight, so I'm just going to skip by that. Maybe next time we'll discuss some slight problems with that camera. And so there's M31. This frame was captured on November 8th. The other two were captured the succeeding night. And I had to do a little bit of tricks with the computer because the sky was a bit less transparent for this frame. It was a bit reddish, so the color was a little different, but I managed to get them, I think, pretty close. And then the next, oh yeah, sorry, that obviously there's a lot of resolution to play with in that. You can even start to see some dust in M110 here, and there's a few H-alpha clouds that you can see as well. This next image is the one I'm most proud of. I captured it over 3 nights in October and November. M33, seeing not quite as good there, and it's not quite as dark a sight, so I had to use a light pollution filter. So this is 5.5 hours of acquisition time. Yeah, what can I say? Just leave it there for a minute. There is another galaxy in this image. Maybe some of you know where it is. Down there, magnitude 15.5, little sucker. Things look pretty good on this screen, but if you want to get a better look at these images and other ones that I do have a website if you've got a half decent monitor. Don't bother trying to remember the address there. Just Google my name and astrophotography. And for those of you who have more down-to-earth tastes, I do a lot of mineral photography as well. I have an extensive gallery on mindat.org, and you can find that by Googling me on Mindat. That's it.
Some very, very nice imaging there, Tony. Thank you. Paul Cloninger.
Good evening, everybody. Got a few images for you tonight. The first one is one that I took at the Carleton University. I was giving a talk on astroimaging down there, and then I gave a demonstration to the class on webcam imaging. So we had a kind of a marginal night, but enough to get a halfway decent shot of Gassendi, which is a large crater just on the edge of Mare Hurorum. It's about 110 kilometers across, about 2 kilometers deep, and you can see that the crater itself has been flooded by lava when the mare below it formed. So an interesting crater. All that's left really, oh, where's the laser here? Oops, sorry, got the wrong one. Is the laser the center? Center. You can see that the flooding came in through the breach in the south part of the rim there, and what's basically poking up above the floor is really just a low series of excuse me, of hummocky hills. The central mountains, of course, and there's a system of rills that run through the crater itself. Not the greatest conditions at night, but there's one for you, Rob, there. That's from the 14-inch Schmidt Cassegrain on top of Carleton with just a 2UCAM webcam. The next one is the Helix Nebula. This is one I shot down on Starfest. We didn't have all that great a sky down on Starfest this last summer there, but we had the nights which were kind of average. This is a kind of a tricky object to image anyway because it never rises very high above the horizon from our part of the world. It's at best it's about 24 degrees. The Helix is a planetary nebula. It's in Aquarius, and it's actually one of the closest of the large bright planetaries to us. It's sort of a prelude of what's going to happen to our own sun when it's near the end of its life. There, the nebula itself is gas that's being fluoresced by the brightness of the central star, which is all that's left of the star that created the nebula. Next one, please. This is the Lagoon Nebula, also shot from Starfest. Again, reasonable, well, kind of okay conditions. Again, from our part of the world, it's sometimes a difficult object to image because it only rises about 20 degrees above the horizon, so you're in the soupy part of the atmosphere, but the conditions were fairly reasonable there. You can see this is one of the two star-forming regions that we can actually kind of faintly see with our naked eye from the northern hemisphere. The Lagoon Nebula is fairly easy to see in Sagittarius in the summer sky, and the Orion Nebula is the other one in the winter part of the sky. This is a gorgeous nebula through binos or through any kind of a telescope at all. And what you can see is that there's a lot of dark Bok globules here. These are materials that are actually in the process of infalling to form future stars within that nebula. And the next one, please. The Pleiades. Everybody's probably seen the Pleiades. It's one of the closest star clusters to us here from the Earth. It's only about 440 light years away. A lot of hot, very energetic O-class stars in that. Probably about a dozen of which you can see relatively easily with any kind of optical aid at all. Certainly, some people with very sharp vision have claimed to see up to about 14 of these things. I think that's probably Stephen O'Mara, but. Certainly with any kind of binoculars and that, you can see a lot. It's a beautiful star cluster, and it's embedded with this nebulosity, which they used to think that the nebulosity itself was sort of leftover material from the formation of those stars. But now we know that it's really just kind of part of the interstellar medium that cluster is passing through at this point in time, so not really related to the stars. As I said, a lot of hot O-class stars in this cluster, and the cluster itself has about 1,000 identified members. These are just some of the brightest ones here, and has a radius. The core radius here is probably about 8 light years across. Actually, you know what I did with that? That's just with my 80 millimeter Apo. I actually made a diffraction spike generator using two very thin wires at 90-degree angles, because I thought for this shot with all these bright stars, the diffraction spikes look nice. I don't really like adding that stuff with the computer because I think that's kind of cheating. But so I just put this diffraction spike generator in front of the. Sorry. And that's not cheating. No, because it's a physical thing. So anyway, that's Pleiades. The last one I have for you, this one is for Valentine's Day, considering that's coming up. The one I did for my lady there. This is the Heart Nebula. This is up near. I know. What can I say, right? The Heart Nebula up near Cassiopeia. This is a really a nice object photographically. It's big from our point of view here on Earth. That field alone is about twice the diameter of the full moon there, and you can see structure within this using, if you've got a reasonably large telescope. You can certainly see the cluster within fairly easily, and that is about 7,000 light years from here. And that's all I have for you tonight. So. Thank you.
Very, very nice. And Gordon Webster. I thought the Pleiades looked like a box of diamonds almost, huh? Nice spikes.
Please don't use diamonds and Valentine's Day in the same.
Get a bit expensive. Okay, so M33 for you again, and probably done, no, it was done November 2nd, so not the same night as Tony's, but it was a very, very frosty night out at the FLO. And this was done with the 120 refractor, which left, this is the next one? Right one. Okay, here we have, okay, so this is Billy and the kids. Back in March, Murray Campbell put this out as a Lunar Challenge of the Month, and I finally got a chance to see it. Also, over the past few months, people have been bringing in images with faces. Okay, and so I think it's fairly obvious. There's the mouth, the eyes, the eyebrows. Okay. These two sketches actually were recently published on Astronomy Sketch of the Day website. Yeah. Thank you. Last spring, I showed you some pictures of my wonderful observatory that I built for about $130. And it had 3 walls, a tarp on the backside for a door, and then this slide-off roof which was really not fun to handle at 3 o'clock in the morning when you're cold and tired. So I decided this year that I'd renovate, and I put in 4 walls and a roof, and started off, I just put up the 4 walls and then had to figure out the roof. So what I ended up with, there's another shot. So I ended up with a folding, folds open. I repainted it. It's not a flat black. It's a wonderful designer midnight blue. There you get a hint of it. Put my table out there and left it. Figured it'd be safe carrying it in and out. It froze in place. I haven't been able to get it unfrozen. And it opens both sides. So I have north facing and south facing. She actually loves to play in there. My 20-month-old daughter, when she gets out there, she just loves to play in there. So now with the additions, I'm now up to about $200. It's much more functional. The other thing I did this year, because I take it down in the summer by law, by she who must be obeyed. And so when I put it back up this summer, or this winter rather, I moved it just a little bit. So now when she wants me to come in, she can't shine a light, the flashlight into the observatory the way she used to. Okay? The other thing that this observatory has worked very well for, it's been really, really good at dispelling clear skies anytime they've threatened since the end of November. You know, so I'm actually thinking I might steal Chris's iPad and sit out there, use it as a planetarium. Okay. Now this last, I have another lunar sketch here for you. And as you're probably all aware, a lot of people have looked at the stars and the planets for information and for guidance. And with all the cloudy weather we've been having, I thought I'd ask the moon how long it would be before we start getting decent clear skies again. Pointed my telescope at, correct me if I'm wrong on the pronunciation, Brian, Borealis? Borealis. And here's my answer. See if you can see it. You get it down there? Eon. Thank you.
That's not good news. And then a little note from Bob Olson, who's obviously somewhere a little warmer than we are here. I believe the proper term by Attila is bastard.
That's a complimentary term.
Yeah, of course. Next, please. And yeah, a little shot. What was the comment, Chris, on this?
He sent this shot saying, in case people in this room have forgotten what Orion looks like, because they have cloudy nights every night. Here it is from his balcony.
There we go. Well, thank you, Bob.
And he shot that with a Polaroid, right?
No doubt. Very nice sunset. We spent a few minutes figuring out which it was, but it is a sunset. And I think we had one more from Rolf. Rolf's down south in Arizona right now. I had asked him if he had a recent shot of the great white spot on Saturn, and he replied back, no, but I got a nice shot of the zodiacal light the other night. So this is very recent, up from Arizona. And I think that's it. Yes, okay, so Estelle's pick for the night is The Mystery of the Missing Antimatter. I don't know much about the book other than that, but her recommendation as something to take out from the library and check out for yourself. Reminder again from last time, those who have had books out for a very long period of time, it would be nice if you brought them back so others could take advantage of them. Other than that, invitation to speakers, you're always welcome to come up with a talk. Any of the topics here, you can contact me at my email address, the one in gray there, bill.meeting.chair@gmail.com. A note for everyone, I'm off on a vacation trip for next meeting. So Mike Mogadam will be stepping in my place to chair the next meeting. I guess if you make sure Chris knows about any upcoming talks that you want to do for next time, he'll be able to tie in with Mike on that. Just post-meeting stuff. What is it? If you're interested in the book library, I'm pretty sure Estelle's going to have it open tonight. The equipment loan library, Al was here, we know, because he did the astronomy news. Coffee and Conversation, Art and Ann. You can also see art about membership info or cards if you're waiting for your membership card to come in. See Stephen McIntyre if you want to look into any of the discount magazine rentals. Members are eligible for that. I'm not sure. Is Stephen, has anyone seen Stephen? If not, I believe his email's available off the website, so you can contact him that way. A reminder, our hosts are very good to us, providing the space. They ask that we not wander around the rest of the museum, which is closed right now. So stay to either this room or, of course, the lobby out there for refreshments. Snacks, drinks, or dinner, the usual reservation, I think, is over at Kelsey's, so you can join the others over there. Okay, so thank you all. I hope you've enjoyed this evening's entertainment, and have a safe drive home.